Okay, let's go ahead and do a few more. Once again, I already found the information. Just as a quick refresher, a review, uh, notice how we don't have an x-intercept at all. Remember, that's because in the numerator there's no x, so 2 can't ever equal 0, so therefore there's no x-intercept. Same idea for the y-intercept. The constant on top is 2, but the constant on the denominator is 0, and 2 divided by 0 is undefined, which is why we do not have a y-intercept. So let's go ahead and use the information I already found. Let's talk about those vertical asymptotes though before we do do everything. So x equals 0 came from the factor x, and because it has an odd multiplicity, the arrows will go opposite direction. X equals 3 came from x minus 3, which also has an odd multiplicity, so the arrows will also go opposite direction for that asymptote. Now, this one's really interesting because if I graph my vertical asymptote at x equals 0 and x equals 3, and then also at y equals 0 for my horizontal asymptote, that's all I have. And notice we have no coordinate, or no coordinates at all. This is a problem where you're going to have to plug something in. There will be times that you have to plug a number into the table regardless of the information. So the last few I could have done without a table, minus finding the whole, but this one I have to use a table in order to figure out. Now, using the vertical asymptote information, I actually don't have to plug in as much as you might think. Now, you can choose any side of the curve you want. There's going to be 3 sections because there's 2 vertical asymptotes. You have this left side, the middle section, and then the right side. And just for fun, I'm going to pick the middle section because I like the number 1. It seems easy to plug in. You can plug it into any version, the factored or unfactored version. I'm going to do the unfactored. And that'll give me 2 over 1 minus 3 is negative 2. So that gives me negative 1. So I went ahead and plugged it in. And now that I've plugged it in, I'm going to go to that coordinate. So 1, negative 1. Now, believe it or not, that piece of information gave me, or that one coordinate gave me enough information to figure out the rest of this graph. And let me walk you through that. Now, one thing you need to remember is the horizontal asymptote is kind of like a guideline. It tells you more what's happening at the far ends than it does the middle. So remember, in the middle, I could technically cross through the horizontal asymptote. But the reason I can't in this case is because there is no x-intercept. So if I cross through, all of a sudden I'm introducing an x-intercept that shouldn't be there. Which means that this curve has got to just look kind of like a U shape, kind of like a parabola, just following the vertical asymptotes on either side. Because remember, vertical asymptotes you cannot cross, can't touch those. That's not true for horizontal. Okay, so we found that piece. Now, using the information we know about the vertical asymptotes, so I'm going to start with the x equals 0. Remember, arrows should go opposite directions. So on the right side, it's already going down. So I need to go up, which means my curve is going to be somewhere in this quadrant or in this little section going up. It does not need to look perfect. These are sketches. And then, oops, didn't mean to erase the highlight. Then I'm going to look at x equals 3, and the same thing happens where the arrows go opposite directions. So this one's also going to have to go up because on the left side it's already going down. And we have got our curves. Now, once again, if you needed to, just keep plugging some numbers in and you will figure out what this graph will look like. Let's go to another. Okay, I already found everything, but let's look at our vertical asymptote. The vertical asymptote came from this piece here, and notice for once it's an even exponent, which means the arrows should go the same direction. In fact, this is going to be a really interesting graph because it's going same direction. And then for the x-intercept, it's also even, which means our x-intercept should touch, or if you like to use the word bounce, it'll bounce off of that x-intercept. But we are good to go. We can go ahead and start graphing everything. So we've got negative 1 as our vertical, y equals 1 as our horizontal. Oop. little interesting. Not much better, but that's okay. We've got our y-intercept at 0, 1. I don't know why it's not graphing. There we go. You'll notice this is one of those examples I was talking about where we are right on the horizontal asymptote right now, and that is okay. Remember, it's a guideline for horizontal and oblique asymptotes. And then the x-intercept is touching. So this one's going to be really interesting. Now, it might be tempting to go, okay, well, I'm going to go down over here, but then we'll introduce an extra x-intercept that shouldn't be there. So this should just kind of go up and follow along our vertical. And then remember, right here, it's supposed to, at that x-intercept, it's supposed to touch. So I'm going to kind of bounce or touch off of it and then just kind of follow the horizontal asymptote. Okay, so that's kind of what it's telling us to do at the very end of the graph. Okay, now this tells us, remember, we know that they're supposed to be going the same direction on the arrows. So we've got this is our vertical asymptote. On the right side, it's already going up. So on the left side, it should also go up, which means it should be mostly in this top little quadrant right here. So that's what our sketch should look like, so that both arrows are going same direction on either side of that vertical asymptote. And then you'd be done.